doubt at some point you've heard in the last few months that an asteroid, 2024 YR4, has the potential of impacting Earth in 2032. But what can we do about this? Are we doomed to the same fate as the dinosaurs, or can we actually do something about it? Hello everyone and welcome to Today in Space. As always, I'm your space science podcast host from the East Coast, Alex G. Orfanos. And in today's episode, we're diving into what's going on with this Near-Earth Asteroid 2024 YR4. It's captured the zeitgeist and everyone's talking about it. It's true that this asteroid has a non-zero chance of impacting Earth on December 22nd, 2032. And as each day passes, the percentages of the impact have gone from 1 to 2 to 3%, down to 1. It's all over the place, or so it seems. But it's going to continue to get more refined and changed as we get closer to impact. So what do we do in the meantime? To us, we say let's learn. We need to science out of this one. And we're going to explore the idea of planetary defense, the level of impact if this asteroid actually does impact Earth in 2032, and how lucky we are to have successful missions like DART and HERA to lean on for our Armageddon moment. So strap in and let's dive in to this week's episode. Thanks for joining us. Segment 1. What is this asteroid? In part 1, let's break down what the asteroid is, its size, and the potential impact possible. There's still so much about this asteroid that we don't know, so you're going to see varying numbers because until we're able to get a good view on it, we are just guessing with a range of possibilities. But the estimated size ranges from 130 to 328 feet or 40 to 100 meters wide depending on where you get it. Space.com reported it as 196 feet wide. Gemini South data from the telescope suggested that it's 177 feet wide, but until the James Webb Space Telescope looks at it in March of 2025 using its infrared instruments, expect these estimates to continue changing, and even afterwards. The more data we get, the more refined our estimates get. And as far as its potential impact, you've probably heard of this asteroid classified as a city killer. The reason for that is that the asteroid has the potential, based on the range of size and mass estimates, to release the same energy as a large nuclear bomb, or 7.7 to 7.8 megatons of energy. The more devastating result would be if the asteroid doesn't break up in the atmosphere and impacts the surface fully intact. But it could easily break up into pieces, spreading out the impact damage but hitting more places. There's also the possibility of another Tunguska event, which is an asteroid that actually blew up in the atmosphere above Tunguska in Russia, and it flattened the entire woodland area from the pressure of that event exploding. So regardless, it's something that would be avoided if we can do that. Part 2. How was it discovered? And why does the probability keep changing? Well, this is the story of the humans and the automated telescopes that discovered this potentially dangerous asteroid at the end of 2024. The asteroid was discovered on December 27th, 2024, according to our research. It was discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is a great name, a NASA-funded asteroid discovery program. Now, the ATLAS team, led by astronomers like Larry Deneau, they are the team that did this, but no individual was actually credited with it, just that the ATLAS system was credited with it. But there are actual human beings behind it, running things behind the scene. And ATLAS operates multiple telescopes that continuously scan the sky for near-Earth objects. And on December 27th of 2024, they captured the images of 2024 YR4 as it moved across the sky. And the system uses 100 megapixel images processed by computers in Honolulu to identify star-like objects that move during the exposures that the telescope is taking. And then you distinguish those from the fixed stars in the background, really, really far away. And this detection occurred shortly after the asteroid made its closest approach to Earth, which is when it was bright enough to be spotted by the reflected sunlight. And so our planetary defense today works that this discovery was reported to the Minor Planet Center in Cambridge, Massachusetts, which is apparently, I didn't know this, the International Clearinghouse for Small Body Positional Measurements, marking it as a new near-Earth object, or NEO. And then the automated warning systems flag it because it's now something they found that isn't a 0% chance of impacting. That gets popped to the top of NASA's Sentry list, and the European Space Agency's risk list. And so it was discovered on December 27th, and it made it to that risk list by December 31st of 2024. And then more observations happened from there. Once it hit that list, more discoveries, more astronomers worldwide were contributing to the data using telescopes like the Magdalena Ridge Observatory in New Mexico, the Danish telescope, the Very Large Telescope in Chile, and later the Gemini South Telescope in the Chilean Andes. So while the news and rumors can make you think that no one is doing anything, there's actually a lot of unnamed people in science who are keeping an eye on this while we all go about our lives and sleep at night. So why does the probability keep changing? Well, think about what we know about this new object. It has an unknown orbit, which is a non-perfect circle most likely, and we only have roughly 2 months of data on it at this point, so we only know this much of the circle that is this orbit. And you can fit a lot of different circles and trajectories on just that little bit of data, that little part of the line of the full circle. That's the true path. So while we still don't know a lot about the mass and the size of the rotation, and we still don't know a lot about the mass and size, its rotation, the makeup of the object, which is going to have a big impact on that circular orbit. We also only saw it because it was close enough to Earth that the sun reflected it off the asteroid, and an automated telescope system noticed it. And now that it's past Earth, we don't expect to be able to see it that well with regular telescopes. The James Webb Space Telescope is good at finding dust and anything with heat with infrared, so that will be our best tool to know more way before 2032. And my mind goes to thinking about the people who had their James Webb Space Telescope observations pushed in March of this year so that we as humanity could get more info about this city killer asteroid while it's still close. And, does the whole list of planned observations for JWST now shift, or does one group get pushed to the back of the queue? Let's just chalk it up to things that I would like to know. So if there's anyone on the James Webb Space Telescope team or someone who's had their research postponed, hit me up because I find that stuff fascinating. And while a lot of experts were emphasizing it's a 96.9% chance of a miss, it's still too high, in my opinion, to just brush it off. And I think the public interest is valid. And so the probability has fluctuated from 1% to 3.1%, back down to 1.5%, and now below 1%. So while annoying and kind of anxiety-inducing, that's actually pretty common, apparently. But not something that we should just brush it off and say, it's not a problem. Another reason why I think it's premature for experts and scientists to just say, don't worry about it, it's 99.9% not going to happen. That may be true for the Earth impact, but the more data that we seem to be getting in this early stage, the more the zone moves away from hitting Earth and closer to hitting the moon. And while we might not have to worry about life being impacted on that impact, disturbing the delicate balance we have with our tides that are pulled by the moon, if this asteroid can knock the moon off course, then we've got another problem on our hands that may not be Armageddon, but is not good for the future of humanity if we just brush it away and say it's not going to happen. Part 3, what can we actually do about it? It's a lot, actually, especially as humanity. And yes, even those of us without astronomical tools or NASA or ESA badges can do stuff too. We'll get to that in a sec. But first, what we globally need to do is learn as much as possible about the object, its orbit, its attitude, what it's made of, and its true size and shape. The astronomers, James Webb Space Telescope team, and NASA Sentry and ESA will do this for us because that's what they're paid to do. As citizens of Earth, we can keep talking about it. If you ask me, this is a great time to discuss the importance of a better system in place. Finding a way to add more and more automated detection systems on Earth and in orbit seem critical to me. The faster we find something that comes remotely close to Earth or is just not cataloged, the better we are. We don't need to build something expensive either. In fact, with the amount of these probes that we might need to have this net of automated observations across the solar system, we might be better off with smaller, less expensive drones instead of state-of-the-art, completely customized for max science spacecraft like James Webb Space Telescope. The more we talk about this as citizens, the more likely the discussion happens at the higher levels. Then things get prioritized. From a political standpoint in the US, Congress has the purse, right? So if you're a US citizen, call your Congress people and tell them you want NASA to get more money to work on planetary defense. Put some of the taxpayer money towards building that system that will then make jobs and get people more employed actually making these defense drones, protecting Earth. Another thing you can do is stay curious and excited about this. Don't let headline of something like an asteroid impact make you apathetic to life and get depressed. Listen to this podcast. We'll be here covering this through 2032, and we'll keep asking questions and looking for answers. That might be the simplest thing you can do. And you might be saying, okay, Alex, that's great, but what are we actually going to do about this? How do we actually stop the asteroid? You can watch it all you want, but why don't we just nuke this thing like an Armageddon? Funny you should ask. Let's talk about the DART mission, a real mission that successfully changed the orbit of an asteroid for the first time in human history. The NASA's DART mission was a real-world example of a kinetic impactor, or the sciencey version of smashing a smaller mass into a larger mass to make the bigger thing move. We covered this mission at the time. Go to episode to learn more. But the double asteroid redirection test involved sending a spacecraft to deliberately crash into the smaller body of the binary asteroid system, Didymos. Its mission was to change velocity just enough that over time, its orbits shift away from the other object. We found out that we can use a small kinetic impactor to slightly nudge a dangerous asteroid years ahead of time in order to change its orbit enough to prevent a collision course with Earth. The cool thing about DART, and something we can look forward to from now until 2032, is the European Space Agency's HERA mission, which is going back to that same system that DART hit to observe the aftermath. HERA is designed to provide scientists with critical data about the resulting changes in the asteroid's structure and motion, basically the real results of what DART did to the orbit of Didymos. You can theorize and simulate all day, but the results in reality tell you how it is, and so much more than just simulation alone. This complementary mission is really special and extremely well timed, because we've only ever changed the orbit of an asteroid once at this point in real life and not in the movies. And another successful mission to see how well we did is really essential if we're going to do it for real, with real stakes. Part 4. Why don't we just nuke it Armageddon style? The method most people go for with life-ending asteroid impacts is the classic Armageddon approach, just like the movie. Let's just nuke it. Even though there's a lot of truth to setting up oil riggers to drill into the metallic asteroid to drop the nuke and how tough that would actually be to do that, the asteroid in that scenario is now just split in half with a ton of debris and could just come right back at Earth again. So you made more debris you need to keep track of, and now you have two massive pieces you need to deal with later, assuming that it is going to keep orbiting and make its way back again. So did you really solve anything by doing that? Or did you just make a lot of mess and delay the problem? That's why we like the kinetic impactor method. The sooner you're able to tap the asteroid in its orbit, the less force and mass you need to nudge it away, or the way you want it to. So if you make a system that is large enough to see potential impact asteroids ahead of time, you could add a ton of small drone kinetic impactors sent out to nudge orbits years ahead of time. And this would be a beautiful game of moving the pieces on the solar system game board and managing orbits without adding a bunch of mess to the whole equation. Because otherwise, the nuclear option might save you once, but after a while, those massive things that have broken apart start impacting other orbits, and then even your nuclear option won't work because you run out of nukes if there's a lot of them, or you don't have a nuke powerful enough to move it the next time around. It's really a last-ditch effort, and we're saying we should invest in a better system now so that you don't ever need to strap a nuke on a space shuttle and then sacrifice a crew member just to get it to work. So to close up, Asteroid 2024 YR4 is one of the newly detected asteroids that has the best chance of hitting Earth and impacting lives than we've ever detected at this point. It makes the idea of planetary defense and the potential of an extinction event from outer space real to more people than ever before. While there are a lot of people who see it as inevitable, we showed you today that actually lots of people around the world are taking this very seriously. And we also shared that what we know about it so far and that even in the worst case scenario, it's not going to end all life on Earth if we are unable to stop it. But we also reviewed can be done today since we have kinetic impactors like the DART mission to redirect asteroids. And we have the HERA mission to look forward to so we can learn more about the effectiveness of humanity's first attempt at redirecting an asteroid's orbit. No new technology needs to be discovered in order for us to make a difference. You don't have to be a scientist or work at NASA or ESA to make a difference. In the US, you can call up your congresspeople to tell them to help fund NASA projects for planetary defense because those are the people giving NASA taxpayer money to fund these projects. And if the US leads, then organizations around the world like ESA will put whatever they can towards the effort, and we can work together to save humanity. So fear not, fellow humans. We can actually science the shit out of this one. It just takes stepping away from the headlines just a bit and looking a little bit deeper into what organizations like NASA, ESA, and teams of astronomers are doing behind the scenes. And, of course, you can always count on Today in Space to cover stuff like this. So thank you for joining us in Today in Space. If you've enjoyed this episode, please like, subscribe, leave your thoughts in the comments below. We'd love to hear from you. We have all the links for the research for this episode, so you can go check them out in the description below. This is Alex G. Orfano signing off and hoping you spread love and spread science. Be safe, stay focused, and be well. See you next time.